Okay, example 5. It says to find the exact value of tangent of 15 degrees. Now they're not as kind on this one and giving you, basically telling you how to do it. But they told you how to do the last one, and you can kind of carry that over to this problem. A couple different ways you could actually do this one. I can write 15 degrees in a couple different ways. I could do it as the difference of like a 45. I could think of 15 degrees as a 45-degree angle minus a 30-degree angle. Both of these are common angles. I know all the trig function values for those. I could also do it as a half angle. Let the theta be 30 degrees and 30 over 2. But since we kind of haven't gotten into if we're kind of going in order, the way we learn things, it'd probably be more, they probably were expecting you at this point to do a difference of 2 angles instead of a half angle. So I'm going to set this up to find the tangent of 15 degrees as the tangent of a 45-degree angle minus a 30-degree angle. All right, so I need my formula for tangent of a difference. So here's my formulas. So I'm going to follow the tangent of a difference. So it's a difference, so I use the bottom sign. So it's going to be a subtraction on top. So it's going to be the tangent of the first angle minus the tangent of the second angle. So tangent 45 degrees minus tangent 30 degrees. The denominator is going to be 1. Bottom sign, so 1 plus tangent of the first angle times the tangent of the second angle. And then it's just simply evaluating each one of those values. Tangent of 45 is 1. Tangent of 30 is square root of 3 over 3. And I know some of you guys leave those 1 over square root of 3, and that's fine. WebAssign takes it that way. It's my habit. 1 plus tangent of 45 again is 1, multiplied by the tangent of 30, which again is square root of 3 over 3, or 1 over square root of 3 if you write it that way. So basically we have 1 minus square root of 3 over 3 over 1 plus square root of 3 over 3. Now, will WebAssign take it that way? I think if I remember right, it probably will. I would probably go ahead and simplify this one for myself just because I'm used to doing that. But it's pretty generous in how it accepts things. You might be able to type 1 minus square root of 3 over 3 over 1 plus square root of 3 over 3, and it probably would accept it. But I'm going to think of 1 as 3 over 3, and I'm going to write this as 3 minus square root of 3 over 3. And think of this as 3 over 3, and 3 over 3 plus square root of 3 over 3 would be 3 plus square root of 3 over 3. And then when I multiply by the reciprocal, I invert this one. The 3's are going to cancel out, and I'm going to have 3 minus square root of 3 over 3 plus square root of 3. And then you could even get into rationalizing the denominator, but I know most of you aren't going to do that, so I'm going to go ahead and leave it that way. Okay, this is question 7. This one's going to be a little lengthy just because I have to go through the sine and the cosine and the tangent of the sum of the 2 angles A and B. So again, I'll start with sine. From my formula card, find the sine of A plus B. So sine of A plus B, remember, is sine A cosine B. So sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. Okay, I'm going to need for each one of these, I'm going to need the sine of A, which I'm given, but I'm also going to need the cosine of B. I've got the sine of A and sine of B, so I'm going to need the cosines of both of those to be able to finish these out. So if you know the sine of angle A, you can find the cosine of the tangent, anything else you need, and I'm going to need all those, so I'm going to go ahead and do them all. So it tells me that I have an angle A lies in quadrant 2, so I'm going to draw it in quadrant 2. This is quadrant 2. And its sine is 4/5, so the opposite side of the hypotenuse, 4 over 5, which makes my adjacent side 3. Do the Pythagorean Theorem if you need to, but most of you are going to know 3, 4, 5. All right, so I know all the functions because I've got all sides of the triangle, so this is angle A. All right, and then for angle B lies in quadrant 3, so I'll draw it down here in quadrant 3. Doesn't look like a right angle, but so this is angle B, and I know its sine is negative 8 over 17, opposite over hypotenuse. That means this side would be 15, and so it's negative 15 to the left of 0 there. So 8, 15, 17, do the Pythagorean Theorem if you don't know those common angles. Those are common triples. So I now have everything I need. So the sine of A was given to me. It's 4/5. Cosine of B is, so on the B angle, the cosine would be adjacent over hypotenuse, so negative 15 over 17. Plus cosine of A, so the cosine on the A angle is going to be 3 over 5. Adjacent over hypotenuse, and the sine of B was given to me up here. It was negative 8, so multiplied by negative 8 over 17. So I'm literally just going through filling in what is the sine of A, what's the cosine of B, what's the cosine of A, what's the sine of B, and then I'm just going to finish that calculation. So that's going to be negative 60 over 85, 17 times 5, 4 times negative 15, plus this is going to be negative 24 over 85, and negative 60 and a negative 24 is a negative 84 over 85. And therefore, the sine of A plus B is, no, hold on a second, I have a mistake somewhere here. Oh, I see what it is. This 3 should have been negative. So back up, left off the negative sign there. So this should have been negative 3/5, which would have made this positive. And this would now become not negative 84, 85, but it's negative 60 plus 24, so that is going to be negative 36 over 85. All right, sorry about that. All right, now I have to do the cosine. Same thing, and I've already got these, so it's going to make the work a lot less there. So, all right, so the cosine of the sum of two angles, A and B, is equal to the cosine of the first angle times the cosine of the second angle minus, so for sum, it's going to be a difference, sine of the first angle, sine of the second angle, straight from my formula. Okay, so the cosine of A, negative 3/5. Cosine of B, negative 15 over 17. Minus sine of A, 4/5, times sine of B, negative 8/17. All right, and that's going to, I'm going to simplify, that's going to be 45 over 85. 3 times 15 over 85 minus a negative, so it's actually going to turn to a plus, 32 over 85. 45 plus 32 is 77 over 85. And that is your cosine. All right, I'm going to run out of room here, so grab another card. All right, now I need the tangent. So again, I'm just going to copy down my tangent formula. So the tangent of A plus B is which one we want the plus. So I need to keep these on here so the triangles are there. Tangent of A plus B is equal to the tangent of A plus the tangent of B divided by 1 minus tangent A times tangent B. Okay, so I just really need to know what the tangent of A and the tangent of B is. Well, the tangent of A, going back to my triangle right here, would be negative 4 over 3, opposite over adjacent, so negative 4 over 3 plus tangent of B, negative 8 over negative 15, which would reduce to positive 8 over 15, divided by 1 minus the tangent of A, which is negative 4 over 3, times the tangent of B, which is 8 over 15. All right, and so we got to do a little bit of arithmetic here, a little bit of basic calculation. So I'm going to make this, multiplying the bottom by 5 and the top by 5 makes this negative 20 over 15. So really think of this as negative 20 over 15 plus 8 over 15 becomes negative 12 over 15. All right, in the bottom we're going to have 1. It's going to be minus a negative, so it'll be plus, and it's going to be 32 over 45. 8 times 4, 3 times 15. And so think of this as 32 over 32, which is the same as 1. 32 and 32 is 64 over, oh, sorry, not 32 over 30, how about 45 over 45? 45 over 45, they have the same denominator. So 45, and that was a plus. 45 plus 32 is 77 over 45, and then you're going to just multiply by the reciprocal, so negative 12/15 times 45 over 77. I could do a little reducing here. The 15 divides out 45, it leaves 3. End up with negative 36 over 77. Done. Okay, I have added, this is number 8. I went ahead, we move into now some of the double angle formulas. I've added the double angle formulas onto my note card here, so we have them in front of us. So the sine of 2 times an angle of a double angle can be replaced with 2 times the sine of the angle times the cosine of the angle. Cosine of a double angle has it has 3 options actually, and they're listed there. And then the tangent of a double angle is given there. We need the tangent formula because we're trying to find the tangent of 2 times the angle. So let me just replace tangent of 2a with its identity here. So 2 tangent of a over 1 minus tangent squared a. So to simplify this, I simply need to know what is the tangent of a. They give me the sine of a. If I know the sine, I can find the cosine, the tangent, or any other function. So let me come over here and let's draw it. It tells me it's in quadrant 3. Sine is negative 15 over 17, so this is my angle A. So the opposite, hypotenuse. And so that would mean my adjacent side. Again, I just know that because 8, 15, 17 is a common Pythagorean triple. If you don't know that, do the Pythagorean theorem, and make sure it's negative. Always pay attention to your sign. It's easy to forget that, but that's to the left of 0, so it's negative. So the tangent of angle A would simply be opposite over adjacent, negative 15 over negative 8, which would reduce to positive 15 over 8. That's all I need to substitute in here. 2 times the tangent of a, which is 15 over 8, divided by 1 minus the tangent of a squared, so it means 15 over 8 squared. 15, that becomes 30 over 8, which would reduce to 15 over 4. And this is going to be 1 minus, squaring 15 is 225, squaring 8 is 64. Think of this as 64 over 64 minus 225 over 64. So 64 minus 225 is 161 over 64 negative. And then I'm dividing, so think of this as 15 over 4 times 64 over 161. I can reduce here. 4 goes into 64 16 times. And I end up with 15 times 16, which is, I also lost my negative sign here, I don't want to lose that. 15 over 16, which is negative 240 over 161. That is the tangent of 2a. All right, number 9. So what we're looking for is the cotangent of 2x. Come over here, cotangent of 2x. Now, if you notice on my card, you don't see a cotangent. Okay, don't need to see a cotangent. Cotangent can always be written as 1 over the tangent. So this would be no different than 1 over the tangent of 2x. And I have a replacement for the tangent of 2x. So this is going to become 1 over, and then I can replace the tangent of 2x with 2 tangent x over 1 minus tangent squared x. Now anytime you have 1 over a fraction, you can just flip the fraction, so it becomes 1 minus tangent squared x divided by 2 tangent x, just to simplify that a little bit. Okay. Again, all I need to know, what is the tangent of x? Okay, well, they give me the cosine of x, but if I know the cosine, I can find any of the other functions. I'm going to go ahead and draw it out. And so this is in quadrant 4. Given that the cosine, the adjacent over hypotenuse, is 7 over 7/8, so 7/8. I have to do, this is not a common Pythagorean triple, so you do your Pythagorean theorem. So 7 squared plus what squared equals 8 squared. So 49, that's 64. So 64 minus 49 is, I can't think here, 20, 64 minus 49 is 15. And so x is going to be the square root of 15. So my missing side here, and it's down, so it's negative square root of 15. All right, and so I need the tangent. And how the tangent is of the angle is the opposite negative square root of 15. So it's going to be 1. Let me come down here where I've got a little bit more room. So 1 minus the tangent squared. So I'm going to take, so let me come in here and say the tangent of x is negative square root of 15 over 7. So that's what my tangent of x is. So I'm going to take the tangent of x and square it. So when you square that, well, it's going to be positive for one thing. So it's going to be 1 subtract, but then the tangent of x squared is going to be positive 15 over 49. All right, so when you square the square root of 15, positive 15. Let me just write out what I did here, so in case there's any question on that. So this was this. Okay, and when I squared that, that became positive 15 over 49. On the bottom, I'm going to have 2 times the tangent of x, which is negative square root of 15 over 7. So that's going to become negative 2 square root of 15 over 7. All right, and it's just a matter of a little simplifying here. So think of this as 49 over 49, and 49 minus 15 is going to be 34 over 49, and then divided by negative 2 square root of 15 over 7. And then we're going to flip, and this is going to be 34 over 49 times negative 7 over 2 square root of 15. I could reduce the 7 with that. I could reduce the 2 and the 34. All right, and I end up, don't lose the negative here, so negative 17 over 7 square root of 15. Hopefully I haven't lost. Yeah, that's the correct answer. Okay, so just a lot of arithmetic there, just basic elementary fractions and dividing by fractions, combining fractions. Okay, so number 10, we had one like this in the double angle section of the assignment. I thought this was probably one of the more challenging problems that I saw come up in the assignments, but let me kind of walk through what you do on this one. So the task is to rewrite this expression in terms of just x, given that x is equal to 6 tangent of theta. All right, so what you're going to need to do is basically replace theta with expressions that are equivalent, but they're in terms of x, and we're going to do that by solving this for theta. So let me do that first. So I'm going to take the x equals 6 tangent theta, and I'm going to solve that for theta. So I'm going to divide both sides by 6. All right, so then I need to undo the tangent. So what undoes a tangent function? Not dividing by tangent. So don't think that because this is not multiplied. It's not tangent times theta. It's the tangent of the angle. The angle tangent makes no sense without the angle. They act as one. But how you undo a tangent is inverse tangent, inverse function. So I'm going to say if I took the inverse, basically inverse undoes the function, and so we have to take the inverse tangent of this side as well. So the inverse tangent of x over 6. This is what. Let me move this down a little bit. This is what theta is going to be replaced with. So that is going to be what theta is equal to. So in this expression, wherever I have a theta, I'm going to replace it with this. All right, let me copy the expression down here. So it's theta over 2 minus sine of 2 theta over 4. Well, first of all, the sine of 2 theta, I don't have anything, I'm going to go ahead and use the double angle identity to write that as 2 sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. Okay, and so let's go ahead and interchange. Let's go ahead and replace it, substitute inverse tangent of x over 6 for theta. So the inverse tangent of x over 6 over 2, just replacing this is my theta, all right, minus 2 times the sine of this times the cosine of this. All that over 4. Now, what in the world can you do with all this big mess? Okay, well, I can simplify it a lot for one thing. What does this mean? This sine of the inverse tangent of x over 6. Remember that the inverse tangent is what this is just the angle that's associated with the opposite and adjacent sides being x and 6. So what angle is associated with those sides on a triangle? So this is basically just an angle, and then this is the sine of that angle. Same thing here. This is just the angle that's associated with the inverse tangent of x over 6. This is the cosine of that angle. So let's kind of draw it out here. So the tangent of an angle, let's just make the triangle here, is opposite over adjacent. So this is the angle that this is referencing. The sides are opposite to adjacent x over 6. So this is referencing this angle right here. All right, so I need the sine of that angle. Okay, well I could do that. Well, I need the hypotenuse because sine involves hypotenuse. So I would have to do the Pythagorean theorem to find my hypotenuse. So let me do that. So a squared plus b squared equals c squared. And so all I do is square root both sides. So the square root of x squared plus 36, I went ahead and squared that, is my hypotenuse. All right, and so I have not much room here. So I've got the tangent, inverse tangent of x over 6 over 2 minus 2. All right, so all this is the sine of this angle, opposite over adjacent. So x over the square root of x squared plus 36. All right, times the cosine of this angle. So the cosine of the angle, this is the angle associated with the opposite and adjacent. It's the angle we're talking about. Cosine of that angle is 6 over adjacent, 6 over square root of x squared plus 36. All that over 4. Okay, and so at this point I have inverse tangent of x over 6 over 2. I'm going to go ahead and reduce this 2 and this 4, so it's actually going to be a 2. Multiplying these together gives me, so I've got minus 6x on top, and the square root of x squared plus 36 times the x squared x squared plus 36 is just x squared plus 36. It's like the x squared plus 30, the square root of x squared plus 36 squared. Square cancels square root, it just becomes x squared plus 36. And of course that's over 2 also, so and put that over 2. Okay, and you could even pull a 1/2 out and just have inverse tangent of x over 6 minus 6x over x squared plus 36, and just put the 1/2 out in front of that. Like if I did this, then I wouldn't need the 2's down here. I could get rid of these and just say, it'd probably be a little bit nicer way to write it, and just say that inverse tangent of x over 6 minus 6x over x squared plus 36 in parentheses with 1/2 out there. That would be but yeah, I thought that was one of the more challenging problems. Hopefully you followed that a little bit.